This week we're going to go ahead and talk about rational functions, and we're going to start off by talking about domain and range of those rational functions. So we briefly talked about domain and range before, but how does it apply to functions that have a polynomial on both the top and the bottom, which is actually what we call a rational function. So a rational function is the quotient of two polynomials. So it could look something like this, where you have a function on top is a polynomial and then on the bottom is another polynomial. Now when we graph these rational functions, oftentimes they'll have parts, or there will be a separated graph. You can also think of this as non-continuous because you can't just keep going from one point to another through a bunch of curves. Now, there are some rational functions that will graph nicely. It just depends on the type. So don't take for granted that all rational functions will look like this. There's a wide variety, and hopefully as we get through some examples this week, you'll see all the different types of possible rational functions and their graphs. So why is the domain different this week? Well, in mathematics, there's a universal rule, very, very important rule, and that rule is you cannot divide by zero. That's the rule. Don't divide by zero, because it's just basically taking objects and dividing it into nothing. Well, we know the laws of physics state we cannot just make things disappear, right? They have to go somewhere, okay? So we can't just make them vanish. This isn't Magic Land, sorry. I don't know if you're into that thing, but it's not that. So here's just kind of a couple pictures to help remember to not divide by zero. So this is just like a magic card. But when this card is played, every monster in the game is destroyed. This card does not apply to Chuck Norris. Basically, don't divide by zero, okay? The only person that's allowed to do that is Neo from The Matrix. And I really hope this reference doesn't get old anytime soon, because I really love The Matrix. The original, not the two other ones. So domain and range. Because of this rule that we can't divide by zero, we have to be careful when working with rational functions, since we can't have a denominator, the number on the bottom, being equal to zero. So we can't have that bottom portion be equal to zero. So basically, as a reminder, the domain of a function is all possible values for the input x. So domain is your x values, whereas range is going to be your y values. So for rational functions, the domain is all real numbers except the values that cause the denominator to be equal to zero, because we can't have that bottom equal to zero. Whereas the range of a function is all possible values of the output y, which we talked about. And how we find it, there's a couple different ways to find it. You could find the inverse function and then look at the domain of the inverse function. However, I haven't really taught you guys the inverse function yet, so instead, we're going to go ahead and just graph our function using GeoGebra. Yay, GeoGebra! I know you guys missed it. And then we're going to identify any y values. So the y values are the vertical axis. Any y values that aren't going to work. So let's go ahead and go through some examples. So the first thing that we want to do when we have a rational function, this one is 1 divided by x, we want to go ahead and find the domain. So the domain is always all real numbers except whatever makes the denominator equal to 0. So all you're going to do is take that denominator, this time it just happens to be x, and set it equal to 0. That's the value that will make the denominator equal to 0. So in this example, we can have any value except for 0. It's the only value that won't be allowed for x, because that will cause your function to divide by 0. Now let's look at the range. So the range is all possible outputs. So to visualize all possible outputs, we're going to go ahead and just graph this real quick. So let's grab our GeoGebra. Remember in that input box, we can just do f of x equals, and it was 1 divided by x. I'm going to go ahead and enter, and we can see that this does look very similar. This is the most basic type of rational function. It would be the parent function that we talked about last week. And you can see here that x cannot be 0. If we look at 0 there, x equal to 0 would be a straight line up and down, right? Here's 0. Can't be 0. It doesn't connect with any point on the graph. Likewise, if we zoom in a little bit, well, we don't even have to zoom in, but notice that y here, the only value that y cannot be would be 0, because it doesn't trace to any value. It looks like the graph is getting closer and closer to that y equals 0 value, but never quite touching it. What will those be called? We'll actually talk about that in the next video. But you can notice there that the value that's not possible is 0 for y. There's no way to get that y value. So we're going to go ahead and just repeat that statement of all real numbers, except 0 for y as well. Now you could see the domain a little bit differently. For the domain, you could be x cannot equal 0. That's your one restriction. And the range would be y cannot equal 0. So just to look at those a couple different ways, if you've seen them written differently, those are the different possibilities. So just be aware that there's different ways to write things. Okay, let's do one more example. So find the domain and range of this rational expression or rational function. Now, the first thing we want to do is find our domain. So, of course, to find our domain, we're going to have to take that denominator. Now, this denominator is a little bit more exciting. It's x minus 9, and we're going to set it equal to 0. Then we're just going to solve. Now, this is just a linear equation that we're solving. The largest exponent is a 1. That's how we know it's linear. So, to solve it, we're just going to add 9 to both sides. Not overthinking this. X equals 9. So, in other words, the domain is all real numbers. And I'm going to abbreviate that numbers because I'm lazy. All real numbers except 9, or of course you could write x cannot be 9. That's the other way. Okay, so the range, remember the range is, we want to go ahead and graph this and see what comes up. So I'm going to go ahead and grab my GeoGebra again. Now I'm going to delete my other function, and I'm going to have to type in, I do not have it memorized, so I'm going to just type in the input box, f of x equals, now a good thing to note here is that the numerator should be in parentheses and the denominator should be in parentheses when you're typing these up for the computer program. Otherwise, it won't register correctly. So notice I put that numerator in parentheses and the denominator in parentheses and then divided those two. And what we have here, I have to zoom out a little bit, a lot of it, is you'll notice that it is that two-part graph again. And you'll notice that x cannot be 9. If you look here at 9, it's kind of hard to visualize, but why don't I go ahead and draw the line x equals 9. So you can kind of see that at 9, notice the graph never actually touches. It gets closer and closer, but it never actually touches that x equals 9 line there. And likewise, what value of y does this not touch? If we keep going out, notice it gets closer and closer to that y equals 5 number, y equals 5, but it never actually touches it. We have to zoom in. I know it gets closer and closer and it almost looks like it's touching it, but it actually never touches that value. Oops, lost my graph there. Let's actually do this. Okay. And if we want to, again, we could draw the y equals 5 graph, and you can see that The line approaches it as you look towards the ends. It approaches it, but it never quite reaches it. Okay, so that means the only y value that is not possible is 5. And this will become, you'll understand this a little bit more as we get into the asymptotes and we start to talk about what those lines that I just drew means. So all real numbers except 5. So y cannot be 5. There's no way we can actually solve for 5. Okay, so that was your domain and range, your x and y values. Graphs are really helpful here. Watch the asymptotes video to become more familiar and really understand where these numbers are coming from.